Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is June 21st, 2025. This video is on a research article published in PNAS on June 13, 2025, titled Targeting Ryanodine Receptors with Allopurinol and Xanthine Derivatives for the treatment of cardiac and musculoskeletal weakness disorders. We are diving into the hidden world of muscle weakness and how a surprising old drug might just hold new promise. Let's start with a question. What do heart failure, aging muscles, and ICU-acquired weakness have in common? The answer? Dysfunction in a microscopic gatekeeper called the ryanodine receptor, or the RyR. Ryanodine receptors are calcium channels sitting inside your muscle cells. They're like the fuse box in a house. When triggered, they release calcium, which sparks muscle contraction. Think of them as on-demand calcium sprinklers. We have three main types: RyR1 in the skeletal muscle, RyR2 in the heart, and RyR3 in the brain. When these channels are leaky or downregulated, muscles weaken. That's a problem in diseases like heart failure, sarcopenia, ICU muscle wasting, and rare genetic myopathies. Can we boost ryanodine receptors? For decades, caffeine has been known to activate ryanodine receptors, hence the coffee-fueled energy bursts. But caffeine works at millimolar doses, too high to be safe as medicine. This new study asked, can xanthine derivatives like allopurinol or oxypurinol bind to the same site and safely enhance ryanodine receptor function? The answer using cryo-electron microscopy was yes. How they tested it? These researchers used cryo-electronic microscopy to look at ryanodine receptor 1 structure with different drug resolutions. They used binding assays on rabbit skeletal muscle to see if the drugs made the channels open, and they used mouse muscle strength tests on the extensor digitorum longus. Allopurinol, pentoxifillin, and a designer compound called oxpyrisid significantly increased calcium release and muscle twitch force. Fun fact, oxypyrisid got 70% of ryanodine receptor 1 channels to open, more than caffeine. Caveat: small sample sizes, 2 for binding, 5 for muscle testing. Only short-term effects were studied. It's not clear how these results translate to humans, but the concept is exciting. Ryanodine receptors can be tuned up like adjusting spark plugs in an engine. Here's the key insight. Allopurinol, a drug used for gout, may enhance ryanodine receptor activity, not just by lowering uric acid, but by binding directly to the ryanodine receptor calcium gate. This challenges an old dogma and could spark a new class of muscle strengthening therapies for cardiac and skeletal diseases. So the next time you think about muscle weakness, remember, it might not just be exercise or aging. The tiny calcium gatekeepers called ryanodine receptors could be the difference between frailty and force. Thanks for listening to God Knowledge Doc podcast. Stay curious, stay strong, and as always, keep your calcium flowing. If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by Master MedFacts at mastermedfacts.com.